Without graphing, tell whether the ordered pair 3, 4 is a solution of the system of linear equations. In this exploration, you will extend your thinking about solutions by determining if a given point is a solution of a system without graphing. Let's start with some review. What is a solution? In class, we define solution a few different ways. One way is it's an answer to a problem. Another way, a value that makes an equation true. A point on a line. And finally, from this unit, it's the point of intersection of two or more graphs. In class, we also checked solutions. After graphing a system of linear equations, we can see that the solution is the point where the two graphs intersect, and we could check to make sure that that solution is actually correct. So the point of intersection here I see is 6, 2. And I know that all ordered pairs are in the form x comma y, which comes in really handy when we need to check. So I see the first line, the top line, is x plus y equals 8. So we'll start with that. And now I just want to substitute my x and y values in to make sure that this point makes this equation true. So my x value is 6 and my y value is 2. So now I have 6 plus 2 equals 8. 6 plus 2 is 8, so 8 equals 8, and that makes me happy. Moving on to the next equation, x plus 3y equals 12. Again, x is 6, y is 2. So now we have 6 plus 3 times 2 equals 12. And 3 times 2 is 6, so 6 plus 6 equals 12, and again 12 equals 12. So now I know that this point really is the solution because it made both equations true. So how will this work without a graph? To determine if a point is a solution of a system of linear equations, all you have to do is substitute the coordinates of the point into the first equation, just like we did in that check. Next, if the point makes the first equation true, we'll do the same for the second equation. Well, if that point also makes the second equation true, then the point is a solution. Just a little helpful hint. If the point makes the first equation false, do not even bother checking in the other equation, because right away you should know it is not a solution. So let's do this one together, the one that I presented this lesson with. Without graphing, tell whether the ordered pair 3, 4 is a solution of the system of linear equations. So we have x plus y equals 7 and x minus 2y equals 6. So we'll just start by substituting this point into the first equation. So x plus y equals 7. And I know my x value is 3 and my y value is 4. So it'll be 3 plus 4 equals 7. And I know 7 equals 7. So just by checking the first one doesn't automatically mean it's a solution to the entire system. It just means it's a solution of that one line. So I know the point 3, 4 is on that line. I also need to check that it's a point on the other line. So we have to check the second equation. So x minus 2y equals 6. Again, x is 3, y is 4. So now we have 3 minus 2 times 4 equals 6. Next step, 3 minus 8, because 2 times 4 is 8. So does 3 minus 8 equal 6? Nope. Negative 5 does not equal 6. So since it makes the second equation false, it's not a solution. So this is my justification. The point makes the first equation true, but makes the second equation false. So the ordered pair is not a solution of the system of linear equations. If you have any questions, jot them down and we can talk about them in class tomorrow. I'm going to have you try one on your own. Tell whether the ordered pair 5, negative 8 is a solution of the system of linear equations. So 9x plus 7y equals negative 11, and negative 2x minus 5y equals 30. Try this one on your own. Use the guided practice example that we just did together to refer back to if you're getting stuck. And at this point, you can pause the video, and when you're ready to check your answer, you can press play. Are you ready to check your answer? Okay, well first, we needed to substitute the point, the x and y values of the point, into the first equation. So 9 times 5 plus 7 times negative 8 equals negative 11. Simplify, 45 plus negative 56 equals negative 11. And negative 11 does equal negative 11, so we're halfway there. Now if the next equation is true, then it is a solution. If the next equation comes out to be false, then it is not a solution. So let's see. Negative 2 times 5 minus 5 times negative 8 equals 30. Negative 10 plus 40 equals 30. And I get 30 equals 30. I see 2 checks. I know that this point is a solution to both equations individually, which means it is the solution of the system. So since the point makes both equations true, the ordered pair is a solution of the system. How did you do? I look forward to hearing how you did tomorrow. In this exploration, you have extended your thinking about solutions by determining if a given point is a solution of a system algebraically. You did it without a graph, so that's considered algebraically. At this point, you can turn your paper over and you have 4 questions to complete. Use this, what we just did in the video, to help you, and use your notes also. All right, have a good night, and I'll see you guys tomorrow.